Okay, so we're on day 2 of chapter 4, section 4. So this is day 2. We're going to use what we've learned about graphing in real world applications. And we're really focusing on domain and range today. Sometimes the domain and range are not just all real numbers. Sometimes it's limited to something. Okay? So that's the 2 big things for today. So you might need to pause this video and then take down this question, and then come on back. It says, the number of pages a student can type is given. P equals 4t. Take it down. Where t is time and hours spent typing. The student plans to type for at most 2.5 hours. Graph the function and identify its domain and range. Okay. So this equation that we've been given is P equals 4t. So now this is looking different than what we did the last couple days. How is that different? What does it have? Different variables, right? Okay. So which variable here in this equation is like the x variable in our equations where we have x and y? Which variable here, everybody?
T.
The t, right? So the isolated variable here is like what variable that we use every day?
Y.
The y. So this almost, another way to write it would be y equals 4x, right? That's a very comfortable way to write it because we're used to x and y. But we can use these other variables, right? We can use the p and the t. If we want to use them in the very way that we use x and y, which of these variables would be represented on the y-axis? Everyone? P, right? So go label your axes there. And then the other variable would be on the x-axis, right? And that would be t. Okay, so we're told that the student plans to type for at most 2.5 hours. So that's interesting. That kind of is a limit, right? So we're not being told that this student will go on typing forever. We're saying the student will type at most 2.5 hours. So that's the time, right? Represented by t. So we're going to identify the domain first. What values may we input for t? Okay, that is the input. Those are the input. The greatest value in this word problem says that the greatest value that may be input is 2.5. Do you see that? So how could we describe that if we put 2.5 here? Make the time equal 2.5? May the person type for 2.5 hours? Yes. So we could say it could be equal to 2.5. And then may the person type for over 2.5 hours? So may the t be greater than 2.5? No. But the t may be less than 2.5, right? And then think about the other extreme. What's the least amount of time a person could type? 1 minute?
1 second.
0 minutes? 1 second?
0.02.
What do you think is really reasonable in the real world?
5 seconds.
5 seconds? Is that the shortest amount of time that you could not do something, Nick? 5 seconds?
I can write 1 word in 5 seconds.
But wait, could you type for less than 5 seconds?
Yes.
How much less? 1? Could you type for less than 1 second?
0.00001.
How about 0? Could you type for no time at all? Could you not type?
Yeah.
Yes. Okay, so you're all from the real world. You know that you could not type.
I do sometimes.
Could you? So you could not type at all, right? So you could have a time equaling 0. And then would the t be greater than 0 or less than 0? Greater. So this is what our inequality looks like. This is what most inequalities look like that have a lower extreme and an upper boundary, you know, the 2 boundaries. Okay? So there's our domain. Knowing our domain, we can now find the range, right? So let's go make a table. I'm going to make a horizontal table. And in this table, we're going to put those 2 extremes. The lowest value, I'm sorry, I'm using x and y, that's not right. Let me change that. T and P, kind of on automatic pilot there. The lowest time is 0. The highest Number of hours is 2.5. And now we could choose a couple of other values in between, right? What is greater than 0, less than 2.5 that you would like to input here? Bailey, give me something. What do you think? Okay, we could type for 1 hour. And Jonathan? You could say 1.5. And then I guess we could say 2 or 2.5. I mean, if we wanted to be really detailed, we could add another little spot there and put 2.5, right? And then we would have little increments of half hours. So you could do that if you wanted. But really, we only need, the minimum number of points you need to graph a line, again, is 2. You need 2 points to graph a line. We usually use more than 2 in case we make math errors. When we plot those points, we can see it, that it's a line or that it's not a line. Okay? Go ahead and find the p-value. Okay, so when we input 0 for t, 4 times 0 is?
0.
When we input 1, Bailey, 4 times 1 is?
4.
Thank you, Bailey. When we input 2, Sophia, 4 times 2 is?
8.
Sophia. Didn't they have so many names over there now? Okay, let's let Sophia do this one. 1.5. When you input 1.5. Good job. And how about 2.5? Do you have that one? Good job. Okay, so there, we're not going beyond, are we? We were told that this person's only typing at most 2.5 hours, so we don't go beyond. There it is. Okay, so we could go plot this. There's 2 things we need to do. We need to identify the range, and we need to graph it. So what would you like to do first? You want to do the range? Okay, so the range is represented by what variable? Everyone look, what variable gives us the range? Everyone say it? P, right? It's this isolated variable. It's like the y in our other equations. And so now we're looking for extremes. We had a lower boundary and an upper boundary in our domain, here and here, right? So now we want to see if we have a lower and an upper boundary in the range. We probably do, right? So what's the least value for p, everyone? 0. Put it on the left. And the greatest value, the greatest number of pages is 10. So we put it here. Okay? And when you order these things least to greatest, then the little inequality signs are usually exactly what we see up there in the domain. This person could type greater than or equal to 0, right? But at most, it would be 10. So less than or equal to 10. Okay, so it's a 3-part little inequality. Okay, so now make sure you've graphed it, please. So we have 0, 0. I'm going to allow these to be increments of 10. Look at your graphs. Do you have a scale visible? You need to. We have 1, 4. I have 2, 8. 2.5 is at 10. Okay, so the final step, though, is what? Could a person type part of a page? Like a half a page, a quarter of a page? Yes. So how do I finish this graph? Lauren? You draw. Actually, we're going to just draw a line. But it's not really a line. What is it missing?
The arrow.
The arrow. So shall I add the arrows?
No.
Why would I not add the arrows? Very good. Because we're not allowed to go past it, right? So this is a very specific domain and range. The only values that are true in this scenario are those that are found on this segment, okay? So today you're going to see some lines maybe, some segments like this, where there are extremes, a lower boundary and an upper boundary. And then you might even see rays, where there's like a starting extreme, but then it could go forever in one way, okay? So look for all of those today. Any questions so far? This is a similar situation, but now suppose a student plans to type at most 14 pages. Graph that and identify the domain and range. Again, the equation is the same, which is P equals 4T. But now we're being told something about the number of pages rather than the time spent typing. Okay? We're going to still find the domain and the range, and we're still asked to graph it. Okay? You might want to make a table. The equation hasn't changed at all, so Nick asks if we could just use a table from the previous example, and yes, you could, except that that table doesn't have 14 pages in it. So you might have to do, we've got to do something more with it, right? We're not being limited right now on the time, but we're being told that this person is typing at most 14 pages. So the pages are what is different, right? So what would be the least amount of pages a person could type?
0.
So that's still in our graph, 0. We had that 0, 0 starting point, right? And now we might include some of those values from our previous table, but ultimately, what do we want to see in this table that we didn't see in that table? Don't we want to see that, right? We want to see 14 in its pages, right? So across from the P, we have that upper extreme, right? 14 pages. What other values might we see between those? Say it again. 7. You want to see something like in the middle? And then you can do what you'd like. You know, you could see 10. 10 would be easy, right? I don't know. I mean, do we already have a value for 2? We don't. Okay, so here are the values that we have found. And 14 is the maximum number of pages at most the student will type. We learned that that was 3.5 hours of typing. So 14 isn't going to be visible on my graph unless I do something different with my scale. So I am going to change my scale here to be every blue line represents 2 units. So this is a 20. This is a negative 20. But in my horizontal direction, every blue line represents 1 unit. So just keep track of that when you're graphing, right? And go ahead and graph. 0, 0. At 3.5, I have 14. 2, 4, 6, 8, 10, 12, 14. At 2.5, I have 10. 2, 4, 6, 8, 10. At a half, I have 2. There we go. Again, we have a segment, okay? So let's find the range and the domain. Which letter is our domain represented by? The one that we're operating on. Which letter are we operating on? T. So that's our domain. So the range will be the P, the isolated one, right? Same as we saw on the previous page. So let's start with the domain, the X values, right? These here, the top, the input. What is the smallest value in our table?
0.
Same with our graph, right? 0. What is the largest T value?
25.
So we put them in. And T's could be anything between 0 and 3.5, right? So T's could be greater than or equal to 0. T's must be less than or equal to 3.5. Now the number of pages typed. What is the minimum number of pages? 0. And the maximum? 14. So we could do this student could do anything in between 0 and 14, right? So the pages typed could be greater than or equal to 0, less than or equal to 14, and there's your range. Okay? There's a little extra section here, identifying discrete and continuous functions. We already talked about this year, and so you guys are pretty good at identifying discrete and continuous functions. And so who can tell us? When you think of a discrete function, what does that look like? Nick? What? Small? No, it doesn't have to do with small or large. Jimena.
It doesn't have a line.
It doesn't have lines. What does it have?
It's the dots.
Individual points. Good. There you go. A graph with isolated points. And the other extreme will be a continuous function. And rather than having isolated points, what does it have? Good job,
Continuous.
Jimena. As a line. It's just continually flowing, okay? And there you go. Have fun.